Let's take a look at this indefinite integral. Notice the infinity as the upper limit of integration. By definition, we'll replace the infinity with some letter. Here I just chose p. And we'll take the limit of those integrals as p approaches infinity. Let's ignore the limit for now because we have to calculate this integral first. So let's spend some time on that. It turns out to be quite messy, so get ready for some algebra here. I decided to use a substitution here, letting u equal 4x plus 1, and it turns out it worked. Watch what happens. So as usual, we differentiate our substitution equation and solve for dx, and that allows us to make all the appropriate substitutions. First, I'll replace 4x plus 1 with u, and then I'll replace dx with du over 4. It's important to remember that the lower and upper limits of integration, the 0 and the p, those are still x values. But we can set that idea aside for right now. Concentrating on the integral, I did a little algebra here, just simplified 2/4 to 1/2. And now I integrated this function. There's a lot of messy algebra that led to it, but first watch how I replaced the square root of u cubed with u to the 3/2, and then made the exponent negative since it was the reciprocal of that. Now, this all led to this antiderivative. And the algebra is quite messy. Hit pause if you'd like to analyze that. It's still important to notice that I took an antiderivative of a function of u, but I still have x as my limits of integration. So before I can plug in p and 0, I have to replace u with 4x plus 1, which is what it was the substitution for in the first place. And now I can plug in p, plug in 0, and subtract. I did a lot more messy algebra, and I got this result. If you want to analyze the algebra, hit pause now. And let's recall what we were doing here. Looking at the left side of your screen, we were taking the limit of this integral as p approaches infinity. Well, on the bottom of our screen, we have now simplified that integral, and I can now replace that integral with its simplified form. Now it's time to take the limit. The 1/2 is unaffected by the limit, well, in the sense that the limit as p approaches infinity of a half is a half. And the term on the right side, with the p inside the radical in the denominator, is just going to have a growing denominator as p gets bigger and bigger and bigger. So that second fraction is going to approach 2 over bigger and bigger numbers, and that's going to make that second fraction have a limit of 0. 1/2 minus 0 is a half. That's the answer to this problem.